Hello everyone and welcome to a new lecture. In this video we're going to talk about graph of derivatives. Okay, so basically what I'm talking about is, suppose you have a particular function and you want to see what is the graph, not of the function itself, but the graph of its derivative. Okay, so suppose I have f of x to equal to x to the 2. Okay, if you want to see what is the graph of its derivative, basically all you have to do is just to take the derivative. Okay, so f prime of x equals to 2x, and just graph that. So 2x, if you graph that, that will be the graph of the derivative of x to the 2. Okay, that is very, very easy. But suppose you are not given this. You are given a particular graph, suppose something like that, and you're asked to see what is the graph of the derivative of this particular function. So if this is f of x, they give you a couple of options and they say just choose which graph best represent the graph of the derivative of this particular function. Okay, so that is the idea. So in order to know the graph of a derivative, we will consider a couple of information. And for that, let me give you an example. Suppose I have this function. Okay, it is something like that. Okay, this is f of x. I want to graph the derivative of this function. Okay, so first of all, identify the areas such that the derivative is 0. Okay, at this point right here, the derivative is 0. The slope of the function at this point equals to 0. We have other points in other functions. We might have the derivative to be 0. So for example, if you have a sharp corner, a cusp, or if you have discontinuity, at those points the derivative is 0. But here we don't have those things. We just have the flat line. So at that particular point the derivative is 0. Okay, when you identify that particular point, okay, it's very, very helpful to you. Okay, so we know that at x equaling to 0, we have the derivative to be 0. So whenever the derivative is 0, either the graph of the derivative is touching the x-axis or crossing the x-axis. Okay, that is basically what it means, and we're going to see it throughout the examples that we're going to do in this lecture. So I divided the function into two regions, into this region and into this region, and right here the derivative is 0. Okay, the second thing that you should rely on is whether the function, okay, or more precisely, whether the derivative of the function is negative or positive. You know that this is a positive slope, this is a negative slope. So for example, right here, these are the slopes that we have. Roughly they are like that. So they are all negative. So that means when you are graphing the function on this side of the x equaling to 0, the points that you have to be below the x-axis. Okay? They have to be in this region. Okay? Roughly speaking. Having a positive slope, you are in this region. Okay? That is the second point. And the third point that you have to consider is whether the slope is increasing or decreasing. So as you can see, for this particular function, it is negative. As you go like that, okay, your slope is increasing. Okay, the slope is becoming less and less and less negative. So if this is minus 7, minus 6, this is minus 5, minus 4, minus 3, minus 2, minus 1, and then you get to 0, and then the slope goes bigger and bigger. It becomes 1, 2, 3, 4. Okay, so right here your slope is negative and it is increasing, and right here the slope is, so right here the slope is positive, okay, because they are all like that. It is positive and it is increasing. Okay, so these three pieces of information, identifying where the slope is 0, identifying whether the slope is positive or negative, and identifying whether the slope is increasing or decreasing, these three pieces of information is very, very important to graph the derivative of the function. So basically what I'm going to do is, now I'm going to graph the derivative of this function. I know at 0 the graph of the derivative has to touch 0, so it will touch this point. On this side the graph is negative and it increases, so it is like that. And on this side it is positive and it increases, so it is like that. So roughly that is the graph of the derivative of this function. On this side, okay, right here, it is negative. As you can see, the entire portion of the graph, it is below the y-axis, it is negative. Okay, on this side it is positive, it is above the y-axis. right here it is increasing. Okay, as you can see, it is increasing, and right here it is increasing. So let me show you a tool that we can use on Desmos such that it gives us the graph of the derivative. Okay, so just go to Google and type in Desmos graph of derivative, and this is what we are looking for, derivative function. Okay, basically it gives you the graph of the derivative of a function. So this red curve that we have, this is the function, and this orange dashed curve, that is the graph of the derivative of the function. So we don't need this actually. Okay, so suppose I have x to the 2. X to the 2. That is the derivative, or actually that is the graph of the derivative of x to the 2, exactly like we predicted. So you can use this tool that we have right here in order to practice. So just type in a function that you want, bring a piece of paper, try to draw the graph of the derivative, and then compare your results to the results that you have right here. Okay? So let's go back to the drawing boards and let me give you another example. So suppose we have a function like that and you are asked to graph the derivative of this function. Okay, so let's identify the places such that the derivative is 0. That is the first step. So right here and roughly right here the derivative is 0. It has to cross the x-axis at those points. Okay, it has to be on the same level as y equaling to 0. Okay, so that's a very good indicator at these 2 points. So now the graph is divided into 3 sections, into this section, and in this section. Okay, so what is happening in this region? Well, it seems like the function, or the slope of the function, so right here it is like that, and then it is like that, it is like that, it is like that. Okay, it is very, very negative right here. It becomes less negative, less negative, less negative, less negative. Okay, so it seems like the function, or the slope of the function, it is increasing. Okay, but it is negative. Negative increasing. So it is negative and increasing. How about right here? So right here it is like that, like that, like that, like that. It becomes more negative. It is decreasing and it is negative. So it is decreasing and negative, or negative and decreasing. Okay, so increasing and negative, negative and decreasing, and right here it will cross the x-axis. So right here it will cross the x-axis, or it will touch it. Right here it will cross it, or it will touch it. How about right here? Okay, it seems like the slope is increasing dramatically. So in this region it is positive, definitely, and it is increasing. Okay, so I have to draw something in this region. I have to draw something that is below the x-axis. So from here to here, I have to draw something that is below the x-axis. It will go towards 0, so it have to touch the x-axis, and it has to increase. So roughly, I have to have something like that. And right here, it is decreasing and it is negative. So it is decreasing and it is below the x-axis. So roughly, it is like that until I get to this point. And in this point, I have to reach the x-axis because it has to touch it or cross it, and since it is increasing and positive, so it goes beyond it. So roughly I'll have something like that. Let's delete this. So roughly I'll have something like that. Okay, so as you can see in these two regions, since it is negative and negative, it will not cross it, it will just touch it. But since in this region and in this region, since here it's positive and here it's negative, you are certain that the graph of the derivative will cross the x-axis. So roughly that is the graph, so it is something like that. That is the graph of the derivative of this function. And you can go to Desmos and check out the graph of the derivative, but roughly it has to look like this. So rely on these 3 pieces of information, on finding where the derivative is 0, on whether the graph of the derivative is below the x-axis or above the x-axis, and you know it whether by knowing whether the slope is positive or negative, and see whether the slope is increasing or decreasing. Okay, by that I mean, so going from here to here, the slope is increasing. From here to here, it is increasing. Okay, that is what I mean. Have these 3 pieces of information, divide your graph into the zones such that the derivative is 0, and graph in between, and ta-da, you will get the graph of the derivative. Okay, so I have attached a document to this lecture where you can download it and practice this concept. Okay, and just to let you know, in case you find it confusing how the questions are laid out, on top you have a question. So suppose it gives you a function and then it asks you to find the graph of the derivative, and below it you have A, B, C, D. Okay? Just choose which graph is the graph of the derivative of the above function. That is basically how you have it. So you have a function right here and then choices, a function right here and then choices, A, B, C, D. Okay? So with this, we come to the end of this lecture.